In this video, I will illustrate how to visualize data graphically with a histogram to get some idea of whether two mean values are different. I am using data from Table 3-1 in the Vascular Plant Taxonomy book by Murrell from the 6th edition. And these data are leaf lengths of leaves on the east side and the west side of one particular California live oak tree. And the question was whether the leaves on the east side are the same or different in length than the leaves on the west side. So we have a bunch of data to use to look at that. First thing that I want to do is I want to calculate some summary statistics. So I can calculate the mean by entering a formula, average, and I can double click on average and select the data that I want to use and want to ask Excel to calculate the average. Close the parentheses and hit enter. So my average leaf length is 4.5857, etc. I could retype that formula in the west side box here, or more easily I can just drag this little green box and that copies the formula over. Then I want to decrease the number of significant digits to something more reasonable. Then I'll calculate the standard deviation. Again, there's a formula for this, STDEV. And again, I will copy my east side data array. And I will copy that over to the west side, and I will decrease the number of significant digits. So I can see that my mean leaf length for the east side leaves was 4.589 or 4.59, and the mean for the west side leaves was 3.86. So it looks like the east side leaves are bigger, but there is some variation as indicated by these standard deviations. So I want to make a couple of histograms to see if these data are actually different. So I'll start with the east side data. And there are a couple of different ways you can make a histogram. First, I will just show the simple way by clicking on the histogram chart in Excel. And so I will change for this chart title, I will just make this east side leaves. And then I will make another histogram for the west side leaves. We'll insert a histogram. And I will drag this, maybe I'll drag this side by side so we can kind of look at these histograms side by side. We want to call this west side leaves. So from this visual picture, you can kind of see that maybe the east side leaves are skewed a little bit smaller and the west side leaves are skewed a little bit larger, but both of them have a mean kind of in the middle, and we can see that the bins are different. And so it's a little bit hard to make comparisons using these two histograms. So I'm going to show you how you can make a histogram using the frequency formula in Excel, and then you can make your own histogram and you can put these bars side by side so you can have a direct comparison. So the formula in Excel is frequency, and we need two data arrays. We first need the data array, which we will choose the east side data, and then we need a bins array. And the bins array are the classes that you want to divide your data into. And so I chose these in advance based on looking at my data. So I chose 3, 3.5, 4, 4.5, 5, and 5.5. And that seems like that will divide my data a little bit more finer than these automatic histograms that Excel used. And then I can close my parentheses and hit enter, and I can see that there are 0 leaves in these east side leaves that have a measurement smaller than 3. So that looks like that was calculated correctly. To fill in these other cells, I will select these cells. I will go up into my formula bar and click on it. Then I will hold the Control and the Shift keys and press Enter. And then that fills in all the frequencies of all of these leaf classes. To make sure that I've included all of these 14 measurements, I'm going to calculate the total by using the sum formula. I will select all of these, and it tells me that there are 14 of them, so I know I have them all. Now I want the frequency of the west side, so again, I will use frequency. Select my west side array. Choose the same bins array and close parentheses. To populate these cells, I will select them, click on the formula bar, hold the Control and Shift keys, and type Enter. And so we have a little bit different distribution. Now I should be able to select, I'll try to select with the titles, and I will insert this time a bar chart, and then this automatically, I'll drag this down a little bit, this automatically puts the bars side by side. If we want to do a stacked array, we can use these same data, and we can choose these stacked columns, and this might look a little bit more like figure 3-13 in your textbook, in the Murrell textbook. Okay, so either one of these is kind of useful for showing us the distribution of the data. And I would probably get rid of this chart title. I have the legend automatically, since I chose the labels when I was selecting my data. I will want to enter a y-axis, primary vertical axis title, and this is going to be the number of leaves that had those particular measurements in the bins. So number of leaves. My x-axis label, oops, not this one, x-axis label should be leaf length classes, and this is in centimeters. And that is how you make a histogram to illustrate your data. One last thing is to do a t-test that gives you a statistical measurement of the difference, and that is just t-test. We will select the east side array, comma, the west side array, comma. We want 2 tails, and we want to do type 3 for unequal variances. This is simply the most conservative t-test, and that gives us a p-value of 0.007, which is a very low p-value, which suggests that these two means are indeed significantly different.